Hi you guys, this is the test correction video that you need to watch as the #1 step for being able to retake your exponents test. So I just wanted to go through this checklist with you. You can find this in Canvas. These are the 3 things that you need to do if you want to retake this test. So #1 thing is you're going to watch this video. You are going to do your test correction. So that means you're going to do all of the ones that you missed on a separate sheet of paper, and in this video I will go through each question with you so you can find the ones that you missed and redo those on another piece of paper. At the end of the video there are some extra problems that I want you to write down as notes. These problems are going to help you with completing your ALEX assignment, which is step #2 to complete the exponent rules test retake extra practice assignment in ALEX. You will find that in the exponent rules folder. You can see at the very bottom, it says exponent rules test retake extra practice. So once you have completed that at 100%, you will be able to do the exponent rules test retake. During this video at random times, I will be providing you with the password for the retake. So that way you can do it at home if you need to. You can also come in before or after school to retake your test. This retake needs to be done before January 7th at 3:15 because the end of the quarter is January 9th, and I need some time to be able to make sure my grades are totally updated before I submit them on the 9th. So let's go ahead and move forward with going through the test retake corrections. Okay, here we go. So the first problems on this said simplify the expression in positive exponents. And remember that if you are multiplying like bases, so if both of your bases are the same, like in this case right here, and this case right here, and this case right here, you follow the exact same rule when you're multiplying like bases, and that is you keep the base the same and you add the exponents. So when we have 4 to the 3rd times 4 to the 5th, that is going to be 4 to the 8th. When we have a 5, remember that this is really 5 to the 1st power. We have some invisible math happening here. Even though the 1 is not written there, you need to know that that really is 5 to the 1st power. So 5 to the 1st times 5 to the 5th would be 5 to the 6th. Okay, on the next one, there were not like bases here. So really you just needed to simplify that just like it was. There was nothing to do with that one. And then if we have 1/3 to the 5th times 1/3 to the 2nd, that would be 1/3 to the 7th. So multiplying like bases, you keep the base the same, you add the exponents. On the next one, we are still going to be using that rule. It's just that with the way that this is set up, we are going to need to rearrange the multiplication so we have our like bases together, because we're going to be multiplying like bases in this situation as well. Remember that if we have -7 j to the 3rd, that's the same as -7 times by j to the 3rd. And then we're multiplying that with a 2, and we're multiplying that with another j. So the commutative property of multiplication tells us that we can rearrange our multiplication. We can multiply in any order. So I'm just going to rearrange this so that my numbers are together. The -7 times 2 would be -14. And then j to the 3rd times j to the 1st is j to the 4th. Okay, next one, we have a -4 times by j to the 4th. Sorry, this pen is being a little bit tricky. So -4 times by j to the 4th times by -10 times by j to the 6th. So when I rearrange my multiplication so that I have my numbers together and my like bases together, it's really helpful for us in knowing what's going to multiply with what. So the -4 multiplies with the -10, that's +40. And then j to the 4th multiplies with j to the 6th, and these are like bases. So we keep the j, we add the exponents. This would be our final answer. Okay, so for #2, this was our final answer for 2A, and then this is our final answer for 2B. Okay, next one. The next rule is power of a power. So when you have 3 to the 5th in your parenthesis, and that is raised to the 5th power, I want to expand this out for you so that you really understand what's happening. That is 3 to the 5th being multiplied by itself 5 times. Okay, that's what 3 to the 5th looks like. And then you can see these are all like bases. So we would keep the base the same, add the exponents, that gives us 3 to the 25th. Now, instead of expanding that out every time, we have a rule, the power of a power rule, that says that when we are raising a power to another power, we keep the base, we multiply the exponents. So 3a should have been 3 to the 25th, 3b should have been x to the 40th. Okay, next. On this part, we have the power of a product. And so you have to remember that this is really 3 to the 1st. So 3 to the 1st is being multiplied by a to the 4th, and then that is being raised to a power. So this time we have a power of a product, and that too has to distribute to both the 1 and the 4, so that this becomes 3 to the 1 times 2, which is 2, and then a to the 4 times 2, which is 8. Now, if you left your answer as this, that was great. If you raised 3 to the 2nd power and you said 9a to the 8th, I also would mark that correct. Okay, so on B, again, we have a product, and we have the power of a product. So whenever we do power of a power, we multiply the 2 exponents. If it's a power of a product, we have to multiply the exponent by both of the exponents within the product. Okay, so the x to the 3rd, if we raise that, if we take x to the 3rd and we raise that to the 7th power, that is going to give us x to the 21st. If we have y to the 2nd power and we raise that to the 7th power, so power of a power, we get y to the 14th. Okay, next rule was the quotient rule. So I'm going to go ahead and write this out for you. I'm going to expand it. Remember that with each of these, when in doubt, write it out. So if we have 8 to the 6th, that's 8 times 8 times 8 times 8 times 8 times 8, 6 times. If we have 8 to the 2nd on the bottom, that's 8 times 8. And remember, anytime you have the same thing divided by itself, it's a 1. So this simplifies to a 1, this simplifies to a 1, which leaves us with 8 to the 4th as our simplified answer. Okay. Now on the next one, when we have d to the 10th over d to the 4th, when you are dividing like bases, remember the rule is that you keep the base and you subtract the exponents. So that one should have been d to the 6th. On C, you're dividing like bases again, and you have to remember that if you have a 6a to the 2nd and a 3a to the 4th on the bottom, this part right here, this 6 over 3, that's going to simplify to a 2. That would be a 2 over 1, okay? And then when you have a to the 2nd, I'm going to write this over here, a to the 2nd over a to the 4th, this would be a to the 2 minus 4, which is really a to the negative 2. But then you guys know that in order to simplify a negative exponent, this is really dividing. It's repeated division. So we have to write the a to the positive 2 on the bottom. So that was the final answer for that one, which brings us to our next part of the test, which was simplifying negative exponents. So 2 to the negative 2 becomes 1 over parentheses 2 to the positive 2. X to the negative 5th becomes 1 over x to the positive 5th. When you have 1 over 8 to the negative 2, remember the way that you simplify that one is the 8 to the negative 2 moves to the top as 8 to the positive 2. And then on the last one, D, I gave you this if you wrote it as 1 over 2 to the 5th to the positive 2. But really this, if I take 1 divided by 2 over 5 to the positive 2. So, and then I have my 2 over 5th to the positive 2, and I'm dividing those. Remember that when you divide fractions, you really flip the second one over and you multiply. So this would have become 5 over 2 to the second. We're multiplying that by a 1. And so that would be 5 over 2 to the 2. Okay, so remember for this rule, you are going to distribute that negative exponent to both of these. And then to make a 2 to the negative 2 positive, we take it to the bottom, make it 2 to the positive 2. And then to make 5 to the negative 2 positive, we take it to the top. So that would be our final answer for that one. Okay, next, anything to the 0 power is a 1. So 10 to the 0 power is a 1. 3 times x times y, all raised to the 0 power is just a 1. Okay, so this part I did not count on your test. We're going to be doing a little bit more practice as a class on this part. So on this part, this was not counting on your grade. We'll do some more practice with this, and then I will do a retest on this later. Okay, so now the next thing that we're going to do is we're just going to go through some practice problems like you're going to see in your ALEKS assignment. At the end of these practice problems, I am going to give you the password to be able to retake your test. So once you complete step 2, which is to complete the exponent rules test, retake extra practice at 100%, I'm going to give you the password for the test retake. I'm going to give it to you in this video. That way the students who do this video, you will be able to take the test at home without having to come in before or after school. Here we go. Do these on another piece of paper. So -3 times by p to the -4. What I want you to realize in this situation is the only one that has a negative exponent is the p. So when we simplify this, the exponent of the -3 is a positive 1. So it's not going to go anywhere. But the p to the -4, remember that a negative exponent is really repeated division. So that's how that one would simplify. Okay. On the next one, we have a -5 multiplied by v to the 4th multiplied by 6 multiplied by v to the 1st. Okay, so if I rearrange the order that I'm multiplying in here, we can see that we have a -30 v to the 5th. Okay, next one, the way that you rewrite a negative exponent so that's not negative is negative exponents are repeated division. So this would be 1 over 4 to the positive 4. For this one right here, we're going to simplify this 6 over 30. That simplifies to 1 over 5 as a fraction. And then we have a b, and there's no other like base of a b. And so we're going to leave it as a b on the top. We have a c over c. This is going to cancel to a 1. So we don't actually have that variable left anymore. And then we have a d on the bottom. So this would be your final answer, 1b over 5d. Okay, for this one, we would simplify the 42 over 12. 6 goes into both of those. So we would have 7 over 2. And then when you have y to the 7th over y to the 4th, we keep the base the same. We subtract the exponent. So that becomes y to the 7 minus 4, which is 3. And then on the next one, what you have to remember here, this was on your test. Many of you missed this. You have to remember that the exponent of the -8 is a 1. And so when you're doing the power of a product, inside your parenthesis, you have -8 being multiplied with w to the 3rd, being multiplied with v also to the 1st. So that 2 has to distribute to all of these. Okay, so it has to distribute to all 3 exponents of the product. Okay, so we have -8 raised to the 2nd power. We have w to the 3rd raised to the 2nd power. So we multiply those. That becomes w to the 6th. And v to the 1st becomes v to the 2nd. And then you could simplify this as 64w to the 6th v to the 2nd final answer. And then I wanted to do one more where you were multiplying and you had to use the multiplying like bases rule. So this is really a -1. This is really a -1 times by u to the 4th times by -5 times by u to the 4th. So if I rearrange this multiplication so that I've got my like bases together, sorry, those 4s do not look like 4s. Let me redo this part right here. So this is a 4. Let me see if I can draw that a little bit clearer. And this is a 4. Okay, so -1 times -5 is 5. U to the 4th times u to the 4th is u to the 8th. So that would be our final answer. Okay, now at this point, what I need you to do is you are going to go into Alex. You are going to do the one that says Exponent Rules Test Retake Extra Practice. Once you have done that at 100%, it will allow you to get into this Exponent Rules Test Retake. And the password for that test retake is just retake. Okay, so R-E-T-A-K-E. Okay, so please email me if you have any questions. If you want to stay before or after school any day, I'm happy to help you. You can also come in den time. It's just that den time is such a limited time. There's not a lot of time to get stuff done. So coming before or after school, if you need help, is the best way. Thanks, guys.